Okay, so in the last lecture we have been preparing our data panel example application to get some scripting support. We can quickly start it to remind ourselves what we have accomplished last time. Once it's done compiling, we see here we have a new tab in which we could write a script, and then we can look where we go from there. So first thing to consider is to decide on our architecture. So whether we can run the script at any time or whether the plugins need to be in a let's say started state. Currently the way it works is that on each plugin we have the start and stop command, which makes them start doing things. But in principle we could keep states on the plugins and initialize them as soon as they are loaded. So when we add the plugin, we can configure some things. So in principle with this, the plugin could already be capable of performing at least some operations. And for us, since we want to be able to test the mechanism here, ideally independently from starting and stopping plugins, it will be convenient to implement it such that we will be able to call functions on the plugins from our script, such that Dingsbumster, such that we can do this even without having started the whole process. So we will allow individual script functions to be called whenever we want. So individual plugin functions to be called whenever we want, at least in principle from the viewpoint of the script. But the plugins, when such a function is called, will be able to either return success and do something, or return error that will indicate that this function can only be called when the script is actually when the plugin has actually been started. I think this is a very flexible approach. So first things, we will add here an additional button like run test that will allow us to initialize and run the script. And our goal for the minimum implementation will be to be able to start a script from this button and then have the script write something into the log. And then once we have this functionality, we will look where we go from there. So let's see, data panel age, data panel CPP, we get somewhere our load script function here. So let's do this toolbar, add a separator. It's a vertical bar that's is used to structure menus and the like. And here let's call it run test on test script, or let's call it on run script. And the idea is that the script will have different entry points depending on what we want to do. So there will be a test entry point where we can run a test, and there will be an entry point which will be run when the whole thing starts, and so on. So I think this is a rather flexible architecture which will allow us to easily work with the whole mechanism. Okay, so we don't have much yet. We have just our run test. You can see that the button was created and is where we want it to be here. And let's now look how we implement the rest of the mechanism. So as already mentioned, we will be using the Qt script engine, so we'll need to include a few things into our application. Let's see what all we need. So QJS engine, I think was the name of the thing. And what we will want to add, oh right, we also need to actually activate some additional modules here. let's our thing, and this is it. Yeah. Qt project settings, modules, and if I recall correctly, it's part of the QML package. Qt QML, this one. I don't think there is a dedicated just the engine package. So since the general intention for this thing was to enable the usage of the whole QML infrastructure, and the engine is a part of this, but the engine can be used independently quite nicely, so we don't need to use the rest of the QML stuff. Now that we have added this thing is available. And generally a good approach with such design is to create some own engine class and some own engine object which will wrap the Qt.js engine and expose the parts of the functionality that we actually want for ourselves. So the engine itself is not very, let's say, useful. It always needs to have bindings to our own mechanisms. Only with those bindings it becomes useful. And these bindings can be done in two ways. They can be very simple, let's say, which just means you can call functions in the global scope and that's it. Or you can make very complicated bindings where you can expose own objects with functions and members and everything you want to create a rather complex scripting environment. So let's here add a new class. Add new class. We will name the class let's call it just C script engine. We will derive it either from QObject or from QThread, depending on how we want the whole mechanism to work. So it would be of course convenient to have the engine run in an own thread and then just communicate with our main application. So for this we would derive this from a thread and then create everything inside the thread. Although initially this probably will complicate things a bit more than we might want. So for starters, let's just create it from a QObject, and then we look later if we and how we extend this to be a engine that runs in a separate thread. So we need to add here a few things: QObject and a public constructor, the script engine, Q and parent, and a destructor of course might be useful. Script engine, let's pin those things here so that we can find them easily. Destructor doesn't need to do anything just now, but the script engine constructor will get a QObject, will pass along our parent object. So the first thing we need to add here as a member will of course be our JS engine, QJS engine, which we initialize with a null ptr for the start, and then we can create the engine object inside our engine here. Equals new QJS engine. The thing doesn't need any advanced initialization. We can just say this as a parent, so that if we delete our own engine, the other one will be removed as well, so that we don't need to clean it up explicitly. If we would want to do things with an own thread, and then we might do this differently. Okay, and now we will since here we have this thing, we can create an object of this type on our data panel. Let's see. So the same way as it contains here the plugin manager, it will also get to contain our script engine. Script engine H. Zack. Script engine mpask script engine. And then of course we need to initialize this the same way as we initialize the other one. So just some words. Place is equals new the script engine from this. Okay, and we will need now a function that will set a new script or update a new script. So void, or let's do it a bool. Set script const string reference script. So this thing will set a script on our engine. Now that I think about it, we should probably move the initialization of the script engine here. So, and of course, first delete the old one. So script engine, and here we should add a few more functions. For is valid, which indicates whether a script is a script engine. And so is valid will indicate A, whether a script was attempted to be set, and if it was set correctly. This is equals null. So our approach here will be, for now, very simple. We will just, if the thing fails to pass the script, return an error and nothing more. So as easy as it gets. And since the idea to create a new engine each time we get a string passed is simply for simplicity, so that if we would save some things globally, if we change the script, the old things don't stay around and potentially change the behavior, and then our script would not be quite reproducible. We could in principle also have a reset function that really recreates the engine each time we press the start button, which might be something we want to add later. Okay, so now let's see here to our data panel. Script engine set script. We just get the text from our script window, and then run test, which is missing, so we will add it. And this thing might, well, both of them actually might return an error. So let's create first our int run test, and we will add here this run test function. So set script is not yet completed, we need to be completed, but more important, we need to include include where did we save this? Interface API plugin codes, so that we could use these codes that we've defined here also for our own other scripting related needs, like plugin let's call it scripter for now. We can later of course change it to something more more useful. So we have our engine, and on our engine we can then just call a function to run the script. So engine evaluate, and this takes some name for it, so let's call it just script. And then wait, so first is a script and the name. So this is just our script, and the name is actually already optional, so we can just do it like this. And this set script, the way it works, it already runs the script, but the way we want our script to work is that there should be no global functions. No, so I'll say it differently. There should be no things that are done when the script is just globally initialized, but it should just simply set up some functions which then can be called on the script. I think this will be a more elegant approach. Although the other approach I said would be, of course, that we just make the script running from the top, but I think we should try to make it more elegant. And this thingy here will already return us a value QJS, which might be an error, and it would return an error if it would return an error if our script would be invalid, like it have an invalid syntax or something. And here what we will also want to do is to make some connection so that we can log if something went wrong. So the same way as we did this with the here, the plugin manager. So the script engine will also get a logline function which will behave the same way. Zack signal logline. Script engine H signals logline. So if something went wrong, then logline. Punkt to string. Okay. Good. Okay. So we have this. Now let's quickly see what we can else run on our JS engine. So generally there is not so many things exposed out of the box. So starting the Dingsbumster, running a function here, like calling a function, is already a bit more convoluted, let's say. Let's see. So one simple thing to just run a function is just to use the evaluation function, just have a code like just whatever function would be. So let's say for onTest, the function would be called onTest, and this should just execute a onTest function which has been here first instantiated inside the script. The for the error we could behave here similarly, that we just run this thing, and if it's an error script, run error, and plugin OK, and else other return plugin OK, and else return plugin error. It will be logged already. Yeah, so that should already be good enough for first test. Although what we are of course now missing is some means of communicating results. Alright, well, other things. So we have not implemented this now. We just want to see if we on test if this works without an compiler error, and if we do something invalid, then we get an error that this was not defined. So this already seems to be working. So the next step will be to add some sort of function that will allow us to well, that will just give us some things that we can for example, an own logline function. That would be a convenient thing to create. So go to our script engine, there where we have created it, and let's see. So we want the global scope. So Q_v. We might need to include some things for this to work. Might really need to include some things for this to work, so this will not work out of the box just as it was. Let's add here QML and QML private. That allows us to include additional more specialized files for the engine, and that should make our work a bit easier. Include private slash QV4 engine, correction, dark engine, QV4 engine, let's go p.h and script and object wrapper. Doesn't like this one. Oh, look like there are any typos. Again, Q4. Oh, okay, then might be enough of these thingies. So we have here scope. Okay, that already looks much better. Okay, so when we have the scope thingy, then we can continue. Let's call it scope. And engine handle. Okay, and on this thing, scope.engine global object. Define default property. String literal. Let's call it logline. So in JavaScript we start with lowercase, so logline. We could start of course with uppercase, but it would be generally nicer to do that correctly. So logline, and we'll need a function that will implement our logging. So Q4, oops, Q4, oops, returned value, logline, const Q4 function object, asterisk p, comma, const Q4 value, value v, comma, const Q4 value asterisk arg values und int arg count. So this is quite a generic binding. It just adds a function on the global scope which can have any amount of arguments. So we might want to filter this later on, but for now this is well, this is good enough. So Q4 here scope scope e. So it is quite apparent that this is a bit of a tedious work, admittedly, and the old Q, I think it was called really just QScript engine, that implemented the old SpiderMonkey engine was quite much more user friendly. This new Qt.js engine is mostly really intended for this QML use case, and this is it makes it a bit more complicated to use it if you just want to use it as a normal some normal sort of scripting engine for other purposes. So it might be, of course, nice if Qt would here offer some more just scripting optimized approach, but they deprecated this old engine and did not replace it with anything except, I said, this new V4 engine, which is kind of less friendly to use if you want to use it without the rest of the QML infrastructure. In principle, one could of course use other own things, but since we are using Qt, I think this is a good reasonable solution to just use whatever engines they gave us instead of then trying to get something completely different, yet different from scratch. So anyhow, let's continue. Execution engine asterisk v4 is equals scope punct. It should have a scope punct engine. Yeah. Okay, and basically for our function we want it to be similar to the other one, so we just check if argument count is greater 1, and then we are already happy. So if this is less than 1, we bug out. qv4 and code undefined, just bug out with an undefined return value. And I mean, in principle, let's do it differently. If it's greater equal 1, then we do something, because we will always return undefined since it is just a log function. And what is a bit more complicated is that we will need to get our engine object. Let's see if we can actually easily do it. So Qt is not quite very user friendly in this regard, because it does not allow us easily to resolve which object invoked this engine. So we will need to implement some own workaround mechanism here that would allow us inside the function to find out from where we have been called. So we will implement here a global helper function for this. Static engines mutex q and a map, static q map, which will map from the different from the different engine handles that we can have to our scripting engine objects, comma asterisk engines map. Okay, those things need to live somewhere, so let's put them here since they are static. No longer marked as static. So, and the idea that we will be using here a mutex to access those map is that later, if we potentially introduce multiple threads, that we want this to be thread safe. If we will do that, we will see later. But for now, I think this is a reasonable approach. So here we want, of course, a function get engine by handle. Get engine by handle. Void asterisk handle. This is a very short function, so we can keep it here. Qtex local. we have this Q. Okay, we are missing qmutex apparently, so let's add this here. Qmutex and qmutex locker. Qmutex locker. Reference. And this should be a static function. Qmutex locker. Qmutex, and now return map point value from handler. What's broken? We should stop debugging. Yeah. Okay. Oops, and there is a typo here. Okay. Yeah, and of course we need to populate this appropriately. So when we create and destroy engines, we will here appropriately clean up and remove those objects. So we need a qmutex lock again, so that we are here locked. Zack, and then we move at what we need. What we will need is to get the handle for this engine. So so here we have engine. This gives us execution engine. Yeah, this is what we are looking for. So remove engine handler. If this thing was defined, because if this was null, then of course we don't need to do anything. Then we delete it, we create a new one, and then once we created a new one, we will insert engine handler, comma this. So the map is populated, and here we do our initialization. We need to keep in mind that we need to unlock this, otherwise if you would try to use it from the eval function, print some line or something, we would already run in a deadlock, so we do not want that. Okay, so we have our arguments, so let's go with script engine. Get engine by handle. Right, how do we get the handle? Can get it from B. That's missing. Wait. Just engine. B engine. Okay. Engine and emit per engine log line. Now we need to get the string, so argv is our vector of arguments, the first argument to qstring no throw, so it will convert it to a string and never throw an exception. And we might have flags, so flags here were of type qint32, so qint32 flags is equal 0. We pass them here and add here a check. If arguments is greater equals 2, then flags is equals argument 1 punct to int32 to uint32. Zack. And we already see the advantage of using it over some generic engine. For example, here we have already Qt types like QString available to do something with them. Later, when we have some more time, we might also look into a third-party package. It's kind of like this QWT. It's a third-party dependency made especially for Qt, which adds a full graphical debugger to the Qt.js engine. The old Qt Q script engine, in fact, used that debugger, or let's say its original version, and it was very convenient. But since Qt refocused here, and their use case was mostly just this QML and not general application scripting, the result is that they did not provide a embeddable debugger. You could use Qt Creator to debug the engine here, but this is not quite so user friendly, because you cannot like make an application that would have a built-in debugger. So it's not something that would be deployable to end users. And generally, in for example lab scenario, you would have like one or two people responsible for the software, and the rest would just use it, and you would probably not want to need to teach them how to use Qt Creator and stuff like that. You would just tell them, this is the application, you can press those buttons, and here you can write a script to do something, and then you still might, however, want to have the ability inside of your application to debug this script. This third-party package, called NeoScript-Tools, adds this ability. It is basically a compatibility layer between the v4 engine that is used by Qt nowadays with the old debugger UI that used the old SpiderMonkey engine. And the way it was implemented, it in fact covers most of the features. So there might be like one or two minor features missing, because the engine's inner architecture didn't map directly one-to-one, but it's like 99% feature complete, so it's quite good. And it can be used free for non-commercial use. So for using a lab, it's perfect. But anyhow, let's continue. So we have here our log line. It will write something to the log, so this should work. This is the name of our function inside our script. So let's run it, and I already see one annoyance. The script is of course gone. So before we continue testing, we of course want to make our life more pleasant. So let's add a mechanism when we close the application to save everything to our configuration. So conf, let's call it script. That's kind of not a nice name. Let's call it script text. Script text to plain text. I think this thing will be able to handle line breaks. It will just encode them, but we will have to test this because it's possible that we might need to add some custom encoding. I'm not 100% sure how a Q setting will actually handle multi-line text when confronted with it, but at least from what I know from how it handles like byte arrays, it just encodes them. So my best bet will be that it will probably use a percent encoding URL style to replace the line breaks. Okay, that should already be it. Of course, the first time it will still be still empty. Function on test. We should change this to the typical JavaScript nomenclature with a small on test. I think in our code here we called on test with a capital O, so let's change this, but we won't run it, we just want to see that it will be saved. Close it, and we could of course now review our ini file. Data panel, it's either here, yeah, notepad always, yes, actually it backslash encoded it. That's even nicer. So this is quite good. Of course, you would maybe not want this for extremely long scripts, so the proper approach later on would be to save the script into our own file maybe. But here, really for simplicity, we're just looking for the fastest way of getting something done. So this is it. Log line test. This is a test, and run test, and voila, it already logs. Although I think we should improve this slightly, or maybe not even that slightly. We just need to remember not to terminate with this button, because then it will not save our last script change. Let's add some prefix and actually make a log function. Not like log line here, but let's make a function void log line. The functions are called the same as you see, except for capital letters. So that might be confusing, but this is a legit approach, since you have different case. Since you have case sensitivity, and the idea here is that now here we'll just call the lowercase function, which is the same as defined the same way as the other one. And from here we will then call the uppercase function, just with a small change. So and this of course not an emit anymore, although this doesn't matter. This emit evaluates to nothing. It's just something that you can mark for yourself, that here you are calling a stuff, that here you are calling a slot instead of just having a normal function call, but functionally it's the exact same thing. Log line, and the idea is that we now script message %1 comma arg log line comma flags, and we could later just got line and we could later here add a to do change const string path on defined x. So what flex did we define? I actually don't remember. Let's quickly see here on log line. We actually didn't use the flag, so it's fine. But I said we could use them to, for example, make the text appear in different colors or stuff like that. So if we pass it around, it's quite good. And if you would, for example, define a defined, let's call it error flag, then what we could of course do is we could for example, write script error, script warning, script message, script information here instead of just always just writing script message. So we can quickly test this, but of course we don't expect this to break. Now it doesn't know which one to use. So we can use these double points to indicate that we should link against the one without the name, or what we also could change this name fx function logline, and and this solves the confusion. So both approaches are valid. So when we run our script again, we get now script message test. This is a test, and of course the script is already capable of doing everything JavaScript can do, like let a be 1 and let b be 100, and test. This is a test. Number plus a plus b, a plus b or a plus b. So as you see in JavaScript plus, depending on the context, either is string concatenation or mathematical operation, which is a bit fishy, but it's an old language, and that's how it was created, so now we have to live with that. But as you see, we could already write some somewhat complex program, and the only thing we are functionally essentially missing at this point would be a mechanism, some simple mechanism, how to call more functions. So we now just need to add more functions like call function on plugin or something. Or we could go another approach and make the plugins more complex objects such that they can be exposed to the engine, and then we could have like an object. For example, we would have a global function get plugin, then we provide the plugin's name. The plugin would need to be added here, of course, and then on this object that we receive, we could then just directly call a function by its name. Currently, our plugin interface is quite rudimentary in this regard. So when we see here, we have like some hard programmed function like start, stop, get parameters, set parameters, etc. But for example, we don't have options to change individual parameters. We don't have options to call like flexibly defined functions. If we want to call a function, this function must be defined rigidly on our interface, which depending on our use case might actually not be what we want. So usually if we want the plugins to be integratable, the plugins needs to be easily integrated, let's say it like this, into our script. We would want the ability that the plugin author can just create new functions that are not even known to our application, to our main application, but yet functions which still can then be called from the script, so that our script authors can then just look up the menu of the plugin and see, I have this function and that function and yet another function, and then so that they can call all these functions. The whole mechanism is more or less implementable even in a convenient way, so like that you can really have the plugin object, and then on the object you call the function in the normal JavaScript style with a dot. But what is more complicated is but this is more complicated. A simpler option would be where we just have plugin.call and then we provide the name, because this way for the object we only need to have one binding with the call function, while if you would want to have every single function bound to the plugin, you would need to create an object and define every single function on that object, for which we would need, of course, then to enumerate all the functions that can there be on these objects. So it gets more and more complicated. Qt can reasonably easily create to some extent function bindings on its own, but it is not easy to make it like algorithmic, how to say it, to make it in a way that it enumerates function from a plugin using some call and then creates them. This would need to be done manually, so to say. Yeah, manually, that's a good way of describing it. So first we maybe want to take a look on this simpler, let's say, way of creating bindings, because this is kind of user friendly. And once we have seen how to do this, we can then implement some more custom approaches. So let's create an object for our engine. For simplicity, let's maybe add a new folder. Let's call it engine and let's move everything there, because for good separation we might want to add various objects, or what we of course also could do is just to define everything in one file and later divide it apart, but this would not be the most elegant approach. Add a new class, so let's call it J plugin. We will keep the J in the name since we already have just plugin without anything, and J indicates that it's a well, JavaScript, in this case binding for the existing plugin, and we will derive it from QObject as it's capital O, as it's necessary. Zack. Okay, we move those two plugins to our engine, that we have everything in one. Oops, I moved the wrong plugin. J plugin. We still have time to mm, change the name. I to make it less confusable. Let's do that. Rename. Let's call it not chain, but object plugin. The better name would be plugin object, but we want something that like prefixes everything that it's easier to. Although once we have moved this where we want it, it doesn't make sense. So let's keep it with an approach that will make it nice later on in the code, and which will keep the file name still aligned. Okay. So this of course needs to be changed. Plugin object. Plugin H, this does not need to be, this needs to be changed. Plugin object, since we have it like we could still prefix it with a C, since it's a, no, let's prefix it with a J. Let's it like this. Right, okay, so we have your object, Q object, of course this Q object, like always, public. Then we need a constructor for this thingy, and what we will want to do is we will want to somehow keep track of our existing object of our plugin. So there are a few approaches how we can do that. One would be that we just create this here. Wait, why is this complaining? Yeah. So one option is of course that we just add a pointer to our plugin, and then if we are adding this pointer, I think the plugin in the plugin manager, where's the plugin manager? Here we use this plugin pointer. So ideally we would use a weak pointer version of this, so that if it goes out of scope, we can capture it. So let's include the plugin hash include plugins plugin H. We should actually probably put all those things into our own folder like we did here with the plugin stuff. Demo panel, like plugins here. We could actually do it, so let's do it quickly. Remove, not delete, save. New folder, engine, plugin object and script engine. And now we re-add it to our project. We will need to fix one thing here. Script engine now lives under engine, script engine, and here plugins, we need to exit one level. Okay, so weak pointer, it's a plugin. Oops. The plugin const weak pointer, let's say plugin. Actually, we could first go with the strong pointer and then create a weak pointer internally pointer per plugin. We also do we need anything else? Not really. We will not add here the standard QObject parameter, because once we have created the object and passed it to the engine will take ownership of it. And protected, here we add a weak pointer, Q weak pointer, the plugin mp plugin. We might also want this things to keep a reference on the engine they belong to. We will decide this once we are far enough to decide it. For now, let's go with this. Oops. And plugin is equals per plugin per Okay, so we have our plugin, we have our object, and we need a few functions which we'll be able to call from script. So let's go and define one, q invocable, q invocable void. Let's see, what would we want to do on the plugin. Well, let's give it a function that will allow us later to call arbitrary other functions. So call. And we don't want void, we want it potentially to return a value. So qjs value call, and the thing will need well, a name. Const q string reference name or function. Let's call it fx. And now what will be a bit more complicated is we want to somehow pass a list of arguments. So what we could, for example, do is we can pass an array of arguments. So q const q variant list reference args, and that's it. So the call will take a string as name and the array of arguments for that function, and then the function will be invoked with said arguments. So we need, of course, now to implement the body of the function. We don't need the invocable thing anymore. Oops. And actually we should do one more change. We should make this argument optional, because sometimes we might just want to call a function which does not take any arguments. So this will be here an elegant approach. And for now we can just return whatever we want. We don't need to return anything specific. Let's like a string, like let's say we just return no, 0. That will be automatically converted. Okay. So now we need to install this object into our plugin. So this, of course, we will need first to instantiate as many plugin objects. So when you go to our script engine, here where we started doing those things, set script, we'll need to query the plugin manager, and for this we will need to include data panel h, so you can access the GUI and then plugin manager. What was it? Get. Well, let's see what we had here. No, get plugin. That is one. We should have a list somewhere. Plugin, but this. Okay, this is then the name is wrong. It should be like get plugins or get plugin list. Since it returns the whole list, so let's fix it. Get plugin list. Zack. Okay, let's go back to our script engine. So here we have our get plugin list. So for auto reference per comma get plugin list. Okay. So we have the plugin. We can get name. String name is equals name, and now we will create an object of this type. So like we did it here, engine global object property. That will that be so easy. Let's see. Global object set property. Yeah. Let's take the plugin's name and need to create a new object. How do we do that? Engine. Create queue object. Nope. One moment, please. I need to recollect how this was working. New queue object, and that should be it's not created, just new queue new. Nope. That should be directly on the engine. That should be even easier. This one. New queue object. New plugin object, which takes the plugin as an argument, and we need to include this thingy. Okay, that should be as easy as it needs to be. Okay, let's then try it if we can call it, but first we need to add a breakpoint here so that if we call it we will see it. Wait, what did we... something is not quite right. Plugin. Okay, let's see. This we don't care. Do we define an own max somewhere? We might need to switch to a newer language version. Let's try that first. That's a quick try. I shouldn't have been rebuilding it. Now it will be also built in the QWT library. No, that's still is not happy. It was our first error. Define. It doesn't like the Windows include. That's solvable. But did we include any Windows stuff in our standard header? Not here. Script engine. Plugin object, and plugin object includes, I think, the interface, which includes Windows. That's annoying. How can we fix that? Plugin object. We can see if we can make it work without this include. We just forward declare the plugin here. Qs. Q, Q shared pointer. Okay, so we will, like inside here, we might not run into this issue. But we need to include this here then instead. Okay, let's see. No, it's still not happy. Because we also have that might be a bigger problem, because we also have included where is it here, our data panel, which includes the plugin manager, which then in turn includes this plugin interface. This is not great, because I think the Windows include we would want to keep that. Although we could, I guess, make it work without it. Was this defined? Demo plugin framework, but this is just in the plugin. We should not include demo plugin. This one, this demo plugin contains all those things. Plugin manager, plugin H. There's the Windows H. But that will cause first probably some more compiler errors. This thing. Okay, so we will. We could move this into an own CPP file, but there is something else we could do. We can use the STL's own atomic reference, atomic implementation. Std atomic what do we want? Int 32 f null so interrupt add punkt where we have included this, that should be that should be fine, but the IntelliSense is broken. Great. That might be more user friendly. But it's not. Okay, so let's go to atomic. We want to add. Let's see. Oh, we leave this as was. Std atomic and this we don't have here. What's the fastest, quickest fix for this? And then we have to do it without the IntelliSense. I think this should have an add value where we can just add what we want. One. This. Yeah. Nope. Okay, I did not expect this to run into such a problem, because this is quite quite annoying that it does not that it's so incompatible with the Windows include that we had that we have used. And the STL atomic okay, and the other one will be fetch subtract. We have here ref fetch sub. I subtract 1, but this thing gives us the value, if I recall, the value before the subtraction happens. So if this is 1, then it should deallocate. Let's put a breakpoint here and evaluate this, and I think this should be it. So let's see. I got the M. That of course is a that explains why it didn't want to show us what functions we have available. Good. And now this compiled, so let's run it. We are not doing anything with the plugin, so let's add the plugin. That's of course a problem. The names should not contain spaces. That will not be valid. So we need to improve on our function here. Name replace space with underscore, and we should also to lowercase the new object. I forgot something. One moment. Let's copy this. We need this part of the code. That's how it should be looking. Set property. Why is this not happy? Global set property name. We will need to lower und ja, Latin 1 Punkt Constata Q-string literal. I think this wants a Q-string. What does it want? Nope, that wants a different name. Wait, that's easier. We just take engine global object set property, and that will be happy with our Q-string. But we still want to make it to lower, so that we have just lowercase and what's still complaining? That needs a dot. And I forgot here. No, I removed it. Yeah, good. let's run it. Script. So we want our, first we add a plugin, let's call it test. So we have fetch 2, we subtract 1, and we didn't break, and now we have 1, we subtract 0. Yeah, okay, so this is working correctly. So test punct call, then some name and an empty argument list. That should already work. Run, and we ended up in our call with, well, name and an empty argument list. So this binding works correctly. Now I stopped it. And we lost it. This needs improving. Test. Test punct call some function, and now let's give some arguments 1, 2, 3. Run again, so we have our name, then we have here now an argument of 3 variants. This is quite user friendly already, and now we exit correctly so that we have saved this. The downside, of course, is that we will be now always missing the plugin each time. But in principle, we can now easily connect any Qt object here. In principle, we could, I think, also return a Q variant, but we can test this later. And for every plugin, this will be a new object will be instantiated. There are a few downsides, like when we would add a plugin and then edit the script, but then when we run it, it will reset it. So this should be fine. In a more final solution, one would maybe add some flags whether plugins have been added or removed, so that we are on the safe side. The other option is just to always recreate the engine whenever we start something, so with the set script function. So this is also a viable approach, but what we need now will be a mechanism to access our plugin. So first of all, we want it in a more stable version. So shared pointer plugin is equals plugin punct log. So our p plugin is a weak pointer, meaning the plugin might have went out of scope. So we first need to convert it into a strong pointer, and then check if the pointer, if this succeeded, if we got a pointer or if we got a null pointer. Because if we got a null pointer, then we will return some error code. This is mostly here a safety feature. We can of course also log a line or something. The general idea is just that we prevent the thing from crashing further down. We could also return explicitly return an exception, but this would require us to have a pointer on the JavaScript engine object, which actually we could have. So let's add that. So we have the plugin here, and in addition to plugin, we'll add our, this goes here, this goes this we'll need script engine. Zack. This doesn't need to be anything fancy. We just add the engine here as a pointer, a normal standard pointer without any smartness about it, because the object will live for as long as the engine lives. So it's the availability of the engine is guaranteed if we create things like this. And of course now we need to change here. We've added this. Oops. Comma plugin engine plugin here. So return engine throw error, and we can either return something specific or we just write a string. Plugin object. This doesn't like doesn't it like just a string? JS value, that should work with a string. Let's just write error. Doesn't like it. um, um, hmm, does this give us? No. Well, in principle, it takes this QJS thingy, so let's like this. QJS value. Now it's unhappy. Why? Because now it has no return value. That's why it was complaining. Right. So then we don't return anything. We just return 0 or just an empty value. And this would actually work like this. And in principle, it shouldn't matter what we return because it should then bug out. Okay, that's this. It should then bug out once the flow control touches the engine. So it knows that there is an error and it will ignore this return value we have here. But we of course don't want to run in this. So now what we'll add will be the interface to our plugin so that we can, as already mentioned, call arbitrary functions. So on our plugin, abstract plugin, we'll add a plugin status, call function. The function we could do it in two ways. We could make it actually we don't really need an enumerability at this point, so let's just give it a string with the name and that's it. So see my string reference, used this before already somewhere, not really, just here for the label. To my string per name or func name, and we'll add one of our variants, although we want an array of variants, so we go with this here, and we will want to be able to get a return value, so we will pass one single non-const one non-const variant right, or result. Let's call this args and let's call this red. Yeah, that's a good naming convention. So now, of course, whenever we try to create a plug, this is of course null. Whenever we try to create a plugin, we'll run into a compiler error because we are missing a function, which happens, I think, just once. Why is this complaining? Well, let's fix the issues one after the other. So demo plugin is the only plugin we really have currently. So we just will fix it and ignore the others. Demo plugin CVP. Zack. This will of course need to be implemented. For now we just return login error. Login error not implemented. So we have kind of two return options. We can return an error like through the normal return channel, or we could return something more complex as a variant. Currently we can only return up to a string, but later, for example, we could have increased our variance capability to be itself an array of variants. Currently we don't do that, so we have to pass arguments in a more simple way, but we could add this, and that would be a nice improvement. So we put a breakpoint here. We see what else is complaining when we try to compile. Here, what doesn't it like? Oh, sure, it's not this, but mpng. It was a small carelessness. Right, but we have not implemented the use of this, so actually it would not too much. Let's go to our plugin object. Actually, we need to do a few things. So on plugin, we will want to have a function call, which is also missing. So let's do this step by step. Plugin cpp, plugin h. So this is our DLL plugin, which then will have this call function. Let's call it also a plugin status. Call const string reference func name covariant list const covariant list reference args and qvariant ret. And this is a reference but not a const reference, so that we can alter it. Let's see, where do we implement that? No, not here, sorry, that's the wrong place. Plugin factory. We had a plugin wrapper somewhere implemented. Because this thing, oh no, it's implemented here. Okay, so just put it here, that should be fine. Then we make it virtual, but then it means that we might run into this issue on other plugins. But here let's make it null, so that an empty function, so that our other implementations will not complain. Then let's return to the DLL plugin. Was it here? Override, okay. And somewhere here-ish, let's call it. So our DLL plugin without override. Instance call function. We called it call function, so here we should keep the naming convention, so that this is aligned with the other things. Call function. Yeah, this thing wants a myString okay. We have a sample where we used it already. No, we didn't. Okay, so and this just takes a pointer. So I think c my stdb string func name, same name, just lowercase. Do we have a constructor? No, we don't. Then set value from stdb string, so this to stdb string, and here we can just pass a pointer on this. Now we need our arguments. How to create an array of arguments we have already seen. We use this qvar to var in an array, so here we copy this portion. We copied a bit too much. We'll rename params to args so that everything is consistent. And of course here is an args. Damn it. That should be v args. And now it will be fine. Args here and here and there. Right, then we create a like in this function my simple variant v red and pass a pointer to it here, and then my var to q var from red, and we assign this, and int red is equal, so that if we get an error message, error code, we can also pass this out. Okay, so this will work. This will call our plugin. So here we can now int red or iRed, it's like an integer value, so let's use the same name. Okay, call function, comma, name is this, zack, args we need a q variant. Does a q variant list or a q variant? Does a q variant? Right. Let's keep consistent naming. Red, and whereas we can return a red. Can we not? Doesn't this like red? Engine to script value, yeah. To script value from our variant, and this thing, if this is ungleich plugin okay, then we will bug out. String plugin r $1.arg red throw and an empty value. Yeah, that looks like it could work. We are still of course missing an actual implementation of some actual function inside our demo plugin, but we want to arrive at this breakpoint. Oh, we forgot something here. We of course in our default function need a return not implemented, otherwise it doesn't know what to do. Well, we can call some function, it sounds fine. Start. Sorry, it's not start. Run test. Test not found. Sure, it wasn't, because we need to re-edit each time. We should really add something to save and restore the plugins. But as you see, that worked. We arrived here, some function with an own array. So it says count is 3. So for example, from here we could have a log function, I think. Log, yeah, log line. So from here we could create some nice log message. But what we are actually missing now would be something to convert a variant to a string, or to allow the string to always be converted to a variant. But we can edit. So first let's hash include string. So we can of course use STL inside our plugins. It's just not great to use it across the plugin application boundary. Yesterday, string message is equals well, actually we start with a function name. Get data, this is a feature, very good. Plus string v space called with arguments double point. Now this we will be of course printing here. C string. Now for int e equals 0 is less than count. We could actually even improve on that. It's just called if count message plus equals L space with arguments double point. No, let's do it like this. With arguments, then we have our loop that prints arguments. This is not complete. Plus or else without arguments. Without arguments. With arguments. Little oops. Without. Yeah, and now just message plus equals L space plus argument variant, sorry, args at e. What do we have? We have a get string data and get string length. So this is for this get string data, comma gets the length. But this only works now with strings. This is not great. So what we need to add now is some mechanism that will always allow us get string even if type is not string. And this is actually quite easy to achieve, since here value is already a base string, so it can hold something for us. Just make a function, a private function, or a protected function. Void to string const. It's a const function, so let's keep it const. So if this is not, then we call to string instead of returning an error, and then we will have a string because the string will have been made, and this will set as mutable, so that we can change it even though we are here in a const function. So of course, if a safe check, so if this is string, then return. Nothing to do. I mean, by this logic, we could of course just save this call and always call to string, since we're doing this test anyways. And now let's see what types we have. What was it here? None. So we could have those types. So switch type case double, case boolean, case. So then value is equals bool question mark L true double point false break. We should try to make those one-liners, that will make it look nicer. To base string as in 64 break in 64 and double. And if it's none of the above, then we just do nothing. And actually we don't even need this check, because this will kind of do the same thing. Okay, so I think to make it fail safe, let's keep the test there and don't do this check here. This is a bit redundant, but a safe option. So if we run it now, our function, once we call it, of course we need to re-add the plugin again. Test. should be able to something didn't work as expected. It failed at the first argument. Why? But apparently our array is not valid. Intermediate, zack, array 0. This looks valid. Array 1. This does not. What have we done wrong? Plugin array size. Well, apparently we had not enough element. Let's debug this here first. Add test script, run script. So step step step. Okay, step long, that seems reasonable. And the first one was fine, so let's put a breakpoint here and go for the second iteration. The second one is number 2, that should also be a long, yes. And this should be then just set at 2. Variant. Okay, it should have an assignment operator. Where we destroy one. We did not. Okay, let's quickly see what it's doing here. So with assignment, it calls our function, call vector. Okay, it calls here the assignment operator. Let's see what it's doing there. It implemented an assignment operator on its own. It calls the parent, which doesn't do much, and here it calls the string assignment. That should be correct. I'm not sure why this doesn't work here. This technically looks like it should be somewhat correct. Here it even looks fine, so we have type 2. So when we go for arc here, the arc is still in scope. I have 3 of them. That is puzzling. Well, this item here seems okay so far, but apparently the next one is not. So we have some issue with our conversion, and this issue probably was already present in our last code, because we just used one argument and accidentally that worked fine. Oh, that we broke. Why isn't this not correct? This is a vector, so this is memory aligned. This of type simple variant. Okay, I know what the problem is. So our simple variant, here we get the wrong offsets. So we need to create a helper variable for that. Asterisk p variant, and p variant at I is equals reference oriented I, and this relies on this being resized. Okay, both should be resized ideally. Okay. Good. And then we need to pass this one here. That should be weight data. This is a pointer. This is convert from float to const. See my method. We can change this of course like this. This should return. It returns a pointer on a pointer. Is it like this? Oops. Zero reference. This will also not work. That needs to be really changed. So this one, this line kind of is correct, but the whole rest isn't. Where do we have that? Interface here. This needs to be an array of pointers, otherwise we will not be able to make this work. And then we need to make the same fix for the set param and get param. Okay, plugin, demo plugin here. And here, array of pointers, so E. And here, asterisk, params and params. Okay, good. When we compile it, it will throw us an error because we have changed this. We just want to quickly see where we had all those changes here. So we can copy this mechanism. So this is the right approach. Set params. We just replace args with params. And then with params we go for reference p params from 0 and p params here. And here we kind of need the same thing, so this close to the same thing. Params, param datam, also reference. Param 0, but then we are missing param. But then we are missing here the loop, but the loop will have less functionality. We only need to get the individual pointers. Okay. Almost. Pointer reference param null, that seems correct. Args vector dash args. We have some inconsistency. Instance set param. Nope, that's correct. Const. variant pointer that is should be correct. Why does this like this? Counts my variant. This is the exact same definition we have here and not here. Interface here. Const the variant is the exact same thing. That should be fine. Why isn't it? With the call vector resize reference und null. That looks correct. Semi-variant we have we have defined. P-params, semi-variant. Do we have another p-params? Nope. And just v-params here. Let's break it down to see what the issue is. It should not make a difference though. Yeah, it doesn't make a difference, it still doesn't like it. Vector type. And we have a pointer, and data is a pointer of pointers. And it should in principle be able to cast this to... Should not be about... Maybe it doesn't like the const, but that would be odd. Oh, now it's also complaining here, but we had this working. Let's just do it like the halfway. Still not happy. It's something without the with the pointers and the constness. One is like a array of const pointers, and the other one is yeah, this is the but here we of course don't want that. But here it should be shouldn't be const, because there we overwrite the values. Get param. Yeah, this is not const, so they should be happy. Let's see. Okay, we have one more. Here, the same problem. Zack, run. Okay, add plugin, test, run test. Okay, it didn't crash. It crashed later on, but it printed what we wanted. Let's see where the complaint starts. Call stack. Okay, it's our asset because we did not set a return value. This remained at none. So I guess we just add the case none. Return q variant Okay. Add test script, run. Yeah. So now we could add there more functionality, and I think we are already starting to run out of time, so this is a good point to not do too much more. I think what would be a nice, so we need to find some homework and something that is not too difficult. Let's go with data panel. Here we have our on log line. Let's go to plugin codes. Hash define log log message 7 was 0 log info will be 1 log success is 2 is green, log warning is yellow is 2, and log error is red. Here is red. Okay, so the homework assignment will be what's today? 04 12 2025. Use log text append HTML to default black. Yeah, so this should be quite simple. Text. Yeah. Okay, so this will be the homework for the over next week. I have been also looking for on this QWT problem we had before, that the colors here and the bars were not shown. It seems there was a bug in the old QWT 6.2 library. I have updated it to the latest 6.3 library, and as you can see, it works now fine. So I will be re-uploading the QWT test example to the Moodle as well, so that you can so that you have a reference implementation which works correctly. And since this also works, we might in the next lecture add the legend to our data panel. Although actually that is quite a simple thing. Oh, I actually already have it added. Then let's just see if it works, although I'm not sure if I updated the library here. Add the demo plugin start. I did not. Apparently, I did not update the library for here. Let's quickly do that. QWT. What is this? Name QWT test. Bug DLL and lib. Zack. Data panel. Data panel. 64 debug. Okay. Alright, the other files are not required. add demo plugin, and voila, we have here our legend now working correctly. So that was in the end quite a quick fix. Just check for updates of the library and apply it. I think that's that. I will upload the things to the Moodle. I'll stop the recording now.